Hello everyone, I am Priyanka. I am a fellow at a research institution called ATRI. It's a private research institution based out of Bangalore, India. So today I will be taking an example of Jakkur Lake in Bangalore. I will be talking about the drawbacks or the problems with the conventional way of water quality monitoring and how Earth observation can help us in addressing those problems. So, giving you a little bit context of the problem, India is facing huge water quality crisis, and one of the reasons for this water quality crisis is that 90% of our wastewater is discharged untreated into our surface water bodies. Now, if you look at the city of Bangalore, and if you look at the graph on your left, you will see that this population of Bangalore city has doubled in last decade, whereas the infrastructure growth has not kept pace with, especially the wastewater treatment infrastructure has not kept pace with the increased demand for wastewater treatment, and as a result we see untreated wastewater getting discharged into our surface water bodies. Because of this, there is a huge loss in the benefits which are provided by these surface water bodies. We have seen leaks on fire. We have seen foaming and frothing in our lakes, and also there has been water bodies which have thick layer of chlorophyll A and harmful algal blooms on their surface. Now, again, taking an example of Bangalore city, I will be discussing the drawbacks with the conventional methods of monitoring water quality. So this is the map of Bangalore city. It is around 857 square kilometer with 12 million people. And you can see here that Bangalore city is located in 3 valleys, and each of the valleys has a network of lakes. Now, again, the point here to note is that these are not natural lakes, but the man-made lakes which historically were used for irrigation. Currently, these lakes provide multiple benefits such as groundwater recharge, environmental amenities, irrigation water, fisheries, and biodiversity. In spite of providing all these benefits to the local stakeholders, still these lakes face various issues in terms of reported frequent fish kill events, algal bloom, frequent bird deaths events reported across lakes in Bangalore. Now, one of the reasons for the poor management of these leaks is because there is a lack of understanding on the processes which govern water quality and water quantity of these leaks. Now, the reasons for the knowledge gap is that the key variables are very dynamic. Like, because the catchment of these lakes are urbanizing, the quantity and quality of inflows keep varying, like they are very variable. So developing mathematical models for such water bodies and to managing them, it's very difficult, extremely difficult. And then there are trade-offs between the functions under different management regimes. Also, very little is known about on how to manage lakes to serve these multiple functions required from them. Now, at H3, we tried to understand the processes which govern the water quality in the lakes, and for that, we want to understand the quality of inflows, the in-lake water quality, and develop some kind of a database which can help citizens, NGOs, and even government stakeholders to manage the lake better. So we started with the conventional way of monitoring leaks using grab samples. We collected data. We collected samples from the inlet, from the outlet, and from within the lakes, and monitored for various water quality samples. Now, this is Jakkur Lake. Its area is 64 hectares, and it has these interventions, which is like, there's a sewage treatment plant to ensure that treated effluent enters into the lake, and it also has constructed wetlands to ensure that nutrients are scrubbed and removed before water enters into the lakes. So we collected water samples at the inflow, outflow, and at the center of the lake to understand the dynamics, the changes in the water quality with respect to the inflow water quality. Now, again, you can see here that the dissolved oxygen levels that levels during the middle of the day, during the afternoon, are very, very high. Like, they are double of the saturation value, whereas the levels which are required for the propagation of fisheries are just 4 milligrams per liter, which means that the quality of lake is good enough for propagation of fisheries. And this data also confirmed with the data provided by regulatory agency, which says that it falls in category D, which means that water quality is good enough for the propagation of fisheries. Now, in spite of all this data coming from our end, which is a private research institution, and coming from the agency side, says that, like, the water quality is good enough. But in spite of all this data, we were seeing frequent fish kill events at the lakes, which was definitely hampering with the management of lake water quality, and citizens were unable to spin their head around the kind of data we were providing and actually what was happening in the lake. So we tried to change our water quality quality graph sample regime to understand the temporal and spatial variability in dissolved oxygen. And here you can see a graph on your left that water quality dissolved oxygen variability across the depth of the lake. And here you can see that early morning dissolved oxygen levels are below 4 milligrams per liter, which tells you why fish has been dying in the lakes, because fish is under stress as the levels, early morning dissolved oxygen levels are very, very low. Again, we looked at the spatial variability of dissolved oxygen levels, and we found that the upstream and downstream dissolved oxygen levels were very, very different. And we also looked at the chlorophyll A levels, which gave us an idea that almost the lake is always in hyper-eutrophic state, which means that the chlorophyll A levels in the lakes are very, very high, which is leading to this very high dissolved oxygen variability, which further leads to frequent fish kill events in the lake. Now, to address these issues with the grab samples, we thought of, okay, let us upgrade and use ResearchGate standards with IoT to create this dashboard where citizens can be provided with this data, real-time data, and then better actions can be taken, or better decisions can be taken to manage water quality of lakes. So this is how we envisioned a citizen science dashboard for lake, where there is a problem, and then we have these sensors who are monitoring and providing us real-time data on the water quality of the lake, which is informing and empowering citizens, pushing government to take action and to address these problems. But in spite of using all these sensors, when we applied them on the field, what we found was that after a few days, the sensors required frequent cleaning because there were fouling issues. And so we really struggled, and then we said that, okay, it was, rather than becoming a real-time monitoring, it was just like, some person has to visit the sensor daily to clean the fouling. So it was not helping us with monitoring at the lake in real time. So then we shifted to citizen science mode, where we trained the volunteers who were interested in environmental issues to monitor water quality. Now, the first thing was to get these low-cost sensors, which are kind of accurate. So we collaborated with the startups who were developing these sensors. We helped them calibrate their sensors in the lab, in the water quality lab at H3. And once the sensors were calibrated, citizens were trained, and after that, the data was used in the web application by using open source code. We were using this data to upgrade our lake dashboard, and then the data was available for stakeholders, for citizens to take actions. And so these are few pictures from the site where you can see that so for managing water quality and using Internet of Things and real-time sensors, it's a very tedious task. But when we use citizen science, we were able to provide data in the context. So the way we created these lake dashboards were providing data in context where citizens were able to make sense of the data. Like, for example, if nitrates are high, are above 10 milligrams per liter, citizens don't know what to do with the single point data unless and until you provide context of why this particular parameter is important. So that is how the dashboard was created. And so here we argue that to further strengthen our dashboard, the lake dashboard, it is very important to integrate Earth observation to monitor water quality, because we can definitely use citizen science to create these algorithms to calibrate the Earth observation data, which are very apt for the local conditions, for the tropical conditions. And further, then it will help us in improving data transparency, empowering citizens, help with informed decision making, assess the impact of interventions on water quality, and increase accountability. Thank you.